Alright, so I think this is recording. Let's take a look at problem number 8 in our Skill 3 review problems. Find the domain of a function given an equation. Now, we always start out the same way when we have an equation. The domain is the set of all real numbers, excluding any values of x that cause division by 0, excluding any values of x that would result in an even root, such as a square root of a negative number. So I've typed that out for you here. So you may want to pause the video because this you have to know by heart. Hopefully you've done enough of these problems and you've heard me maybe say it enough that it's becoming just second nature to you as much as your home telephone number or your middle name. All right. Now, I don't have any variables underneath the square root, so I don't have to worry about this second part. But I do have variables in a denominator. So this x squared minus 6x plus 8, that represents real numbers depending on the value of x. We cannot allow this denominator to be 0. But it's hard to look at the equation and just by inspection see what values, if you plugged them in there, would result in 0. So we temporarily set it equal to 0 and we factor this. Or if we can't factor it, we use the quadratic formula if it's a quadratic equation. But here I'm pretty fortunate that I can factor this. And we have a zero product theorem that says if you have two or more values that have a product of 0, the individual factors must be 0, or at least one of them must be 0. So either x minus 4 equals 0, or x minus 2 equals 0, or if you have a list of factors, maybe both. Alright, so here if you add 4 to each side, x is equal to 4. If you add 2. Alright, so x equals 4 and x equals 2 are the solutions to this equation. Well, this equation, this expression, we've set it equal to 0. If we plug in 4, if we evaluate this function at 4, then I know that we just solved this equation. I know this denominator is going to be 0. Now the numerator, 3 times 4 is 12, and 12 minus 9 is 3. But the problem is 3 divided by 0 is undefined. So if I'm going to list ordered pairs, or if I'm going to make a table of values, if I have x is 4, I don't have a y value to put here because 3 divided by 0 is not a real number. So it's undefined. And therefore we can't allow 4 to be in the domain. So we're going to exclude 4 from the domain. Same argument applies to x equals 2. If you evaluate this function at 2, you get a 0 in the denominator. Now in the numerator, 3 times 2 is 6, and 6 minus 9 is a negative 3. But negative 3 divided by 0 is undefined. So those are the only two numbers that cause us problems. So I erased everything and I erased my answers. Let me put them back up here real quick, or at least the factoring. We want to exclude the number 2 from the domain, and we want to exclude the number 4 from the domain. All the other numbers in the real number line, all of those, if you plug them in, will produce exactly one y value, one output. Every input has to produce exactly one output for a function. So now we have the task of describing this infinite set of points to people. We can't list them all. So using this interval notation, if the left arrow is shaded, that's a negative infinity. If the right arrow is shaded, that's positive infinity. We say the domain of this f in this left part of the number line that's shaded here, we describe that region from negative infinity to 2. And since 2 is excluded, we have an open parenthesis. Since there's a break on my number line, I have to use a symbol that they call the union. We translate it when we're reading it as the word or. You're in x from the domain is in this interval, or it's in this interval or it's in this one. So from 2 to 4 is my next interval. Since there's a break, I need another union. And then 4, and we never have square brackets around infinity because it's not a number and we can't include it as an endpoint. So here is my domain for problem number 8, and I hope that helps.